Hi, this is Ms. Silva, and for today's lesson, we're going to be going over graphing polynomials. To be successful, we're going to be using the fundamental theorem of algebra, identifying if the polynomial is odd or even, determining the end behavior by using the leading coefficient, identifying the y-intercept, factoring using the rational root theorem if necessary, and then we're going to be solving the zeros using the zero product property. We can sketch the graph of polynomials using a calculator. Be sure that the polynomial is in standard form before attempting to get the key features. So first, let's look at the degree of the polynomial. Using the fundamental theorem of algebra, it tells us that this degree tells us the maximum number of zeros. Well, it is 3, so that means we have a max of 3 zeros. Then we're going to look at the leading coefficient. Since there's no number here, we know that it is a 1. So the leading coefficient is a positive 1. Our leading coefficient tells us the behavior of the graph on the right side. So if it's positive, then it is going to be ending in the positive direction. And for the sake of notes, if it is negative, then at the right side, it's going to end facing down. To determine if it's an odd or even degree, we're going to be looking at the degree of the polynomial. Because 3 is an odd number, we have an odd function. Odd means that our graph is going to be facing opposite directions. So if we know that the graph is ending on the right side, then the left side of the graph is going to be going the opposite. For the sake of the notes is just basically them going in the same coefficient and the degree of the polynomial. We can say that as x approaches positive infinity, that's basically just looking at the right side of the graph. We know that it's going to be going in the positive infinity direction, my y is, and when my graph is approaching negative infinity on x, then that one, we're looking at the left side of the equation. And the left side of the equation we saw, because it was an odd degree polynomial, that it's going to be going in the negative direction. The feature we can get from standard form is the y-intercept. The y-intercept is the constant of your polynomial. Remember, your constant is the number without the variable. If there is no number that does not have a variable, then my constant or my y-intercept will be 0. So my constant is 5 in this example. So my y-intercept. The only information that you can't get from standard form are your zeros. To find our zeros, we need to be sure to factor first. And remember, factor is when we have the parentheses before solving. Points on the graph bounce off from the x-axis. So if we had an example like this, if it had a multiplicity of 1 or it just happened one time, it goes through the graph. But if it has a multiplicity of 2, it bounces off. So an example would be if we have, let's say, x minus 1, x minus 1, x plus 4, this would create the bounce, where x is equal to 1 has a multiplicity of 2. Now let's go ahead and factor so we can find our zeros. We have x to the third minus 5x squared minus x plus 5. So because we have 4 terms, we always want to try to start with factor by grouping. So we're going to group these two and these two. We've got x squared here. My next factor is -1. I'm sorry, my next GCF is -1. So our first factor is x squared minus 1. Then we're going to divide to get our next factor. This gives us x, and this is -5. Because now we've gone over the rational root theorem, we need to check the first group also. So x to the third divided by x squared, that still gives us x. And -5x squared divided by x squared still gives us -5. So these are factored by grouping, or we can factor by grouping. This one we know that we have a difference of perfect squares, so we can get the square root of x squared, which is x. Square root of 1 is 1. So this factors to x plus 1, x minus 1, and then we'll bring down the other factor of x minus 5. Now that we're in factored form, we use the zero product property to make them, or to solve. And that basically just means that we're making each factor equal to 0. Once we make them equal to 0, then we can solve them. This is -1, +1, and +5. So our zeros are 1, -1, and +5. Now that we have all our key features, we can sketch our graph. First, we're going to plot our x-intercepts. Oh my gosh. So we start at -1, +1, and +5. We also have our y-intercept of +5, so I need to plot that one as well. Once we plot all of our important points or our intercepts, we look at the behavior. And remember, on the right side, it's going to approach positive infinity. And on the left side, we're going negative infinity. We're going to start, I like to start on the right side. It doesn't matter what direction you start, but we're just going to go through each one of those important points. And your graph ends like this.